In this video, we're going to do a 1 proportion z interval. We're finally moving on to a new chapter. Before we all talk about mean and averages, but right now we're talking about proportions. So before we jump right in, I want you to think about the difference between mean and proportion. Here are several scenarios. I want you to decide which is mean and which is proportion. First, you're calculating the average number of hours your classmates studied for the last test. Because there's an average key term right here, this should be a mean. What percent of your classmates studied more than 5 hours for the last test? Well, there's no average, so p hat. This should be a proportion. And another thing that reminds you is more than 5 hours. This will remind you to be a proportion on the normal curve. The average number of pages students read from a novel over winter break. Average, this should be a mean. How many students finish reading the novel over winter break? How many students? This should be a proportion. The average number of goals scored per player on the soccer team this season. Average, mean. What fraction of the soccer team scored at least 1 goal this season? At least 1. This reminds you to be a proportion. Average amount of money students spent on movie tickets last month. Because there's an average, this is a mean. Percent of students who went to the movies last month. Percent, proportion. The average number of cups of water students drink in a day. The average, this should be a mean. How many students remember to bring a reusable water bottle today? How many students? Should be a proportion. Okay, after a little bit warm up, let's go to the main lesson today. So, Unit 6, Part 2, we're moving on to learn inference procedures for a population proportion. We're first constructing a 1 proportion z interval. And the question is, when tossed, what proportion of the time will a Hershey's Kiss land on its base? This is a fun activity we did on class, but since this is an online video, I cannot really show you how we did. So I'm just gonna give you the data and the procedures to lead you in to this topic. So our goal is to estimate this population or proportion with a confidence interval. Here we go. Okay, so first, just as always, state, what is P? P is the proportion of all Hershey Kisses that land on their base. Second step, name the procedure. And this is a 1 proportion z interval. And then checking the conditions. This is a simple random sample. We met the 10% condition. And NP hat and NQ hat should be all greater than 10. Reminding you that these should be P hat and Q hat, not P and Q, because we're dealing with samples, not populations. And this concludes that sampling distribution is approximately normal. Third step, do. We're actually doing the calculations. And we're using P hat plus or minus Z star times the square root of P hat times Q hat all divided by n. And we should get an interval of 2 numbers. The last but not least is conclusion in context. And this basically has to allow you to explain what does p hat really means in this question and what should you conclude about. So let's really plug in the real values and see how it goes. First, as always, P, as we stated before, proportion of times Hershey Kisses land on their base. Second part, 95% z interval for 1 proportion. Those are the conditions I already stated. You can just feel free to take a glance. Third step, state what is p hat. P hat is 0.25, and this is the value that we did in class. Then use the formula to calculate the interval. Should be 0.165 to 0.335. And then conclude. I am 95% confident that the true proportion of times the Hershey Kisses land on their base is between 0.165 and 0.335. So that's it for this question. And then I drew a graph right here, a rough sketch of the graph. This stated that in class we collect every student's sample. So in reality that they all build a z interval for their data, and I collect all of their z intervals and draw them on a line right here. You can see. So you can see that not all number lines lie in the same position. but roughly they have the same length, which is good. And you can see that if we plug in the numbers on the line right here, the true p, or the true proportion, is going to be somewhere right here. And not all number lines capture it, which is fine because we're only 95% confident. And there's definitely have to be 5% that lies outside of it. Or not have to be, but that's what we predict. So that's it for this video. I hope you learned something of how to do a 1 proportion z interval, and basically everything about Hershey Kisses, and have fun.